All right, so coding session time, Bangalang time, and to be honest with you, I'm kind of enjoying refining the language. I feel like as we've gotten deeper into it, I've gotten more ideas about what I would like the language to be, like how I'd like it to be structured, how the grammar should be. I'm enjoying kind of creating more of an elegant grammar, and I think I want to refine that a little bit more, because as we get into some of these more advanced features and the code gets more complex, I just feel like it's good to get this nailed down first. Otherwise, refactors are just going to be that much harder. That's kind of my thinking, and also my preference. It's just what I would like to do. So we're going to do some more language refinement today. The main thing I would like to do is take this procedure production and merge it into the assignment, because really it's really just an assignment, right? Like if we look at this here versus this here, well, I guess this one doesn't actually assign anything. But let's say we were able to assign something to it like this. We have like the name of what we're declaring, colon, the type of it, and then equals, and then some value. So maybe to do something more concrete, if I were just to say like my num i64 equals 1, so this is the same format. You see here we also have the same format. We have the name, the colon, this here is the type. It's a procedure that takes a struct as a parameter. It could also have a return type. That would also be part of the type. And then we have equals, and then we have the value. In this case, it's a single statement. It could be a scope. This would also be valid, and we could have multiple statements in here. So it's the same. This statement has the same structure as this statement, and I don't like that we have this special case up here. I want to reduce the amount of special cases we have, so I want to bring this procedure into the assignment. Right, so how do we do that? I think the first thing is we want to take this over here and create like a procedure type, which is, I guess, everything after the colon. And this extern, actually, this directive, I think what I'm going to do is change in this general type thing. I'm going to change that to just a general directive. I'm not going to define directive right now because I'm lazy. So this is struct type. So let's put procedure type in here as well. It's a data type. And then so it's like proc, and then we have all the parameters and the return type, and we don't have this anymore. Actually, that reminds me, I found these triple ones, and I think there was one that has space when it doesn't need to. And this return I want to put here because I'm picky about ordering. Okay, so now we have a procedure type which is proc, opening bracket, and then all this parameter stuff, closing bracket, and then optionally it has arrow type for the return type. And the data type could be a struct or a procedure or any of these predefined types. So that should mean that this left-hand side expression can handle procedures, but the right-hand side is a right-hand side expression. And for procedures, it needs to be a statement. Let's cut this out. It needs to be a statement. So we kind of have two options now. I need to change my keyboard. Always forget about that. So it could be a statement or a right-hand side expression over here. So we're going to have to do some logic around that. And I think that's kind of it. That should be all the grammar changes we need. This might not look great. We're going to improve this later on. I have other ideas to improve it, but I think this is kind of a step in the right direction. So this procedure type as part of data type or as part of type is actually kind of already done. If we go into parsing, if we go to parse type, it already handles procedures. So that's kind of sorted. So let's see what parse procedure has in it. Where's parse procedure? We create a procedure node. We have an identifier, a type, and equals statement. So it's fairly simple. I think actually we can take this out altogether. And I'm just going to kill this. Just a second. Here's with the door. Okay. The cleaner came to clean, but she won't be coming up here for a couple of hours, so it's all good. So we don't have the special parse procedure anymore. We just have parse statements, so that's a nice simplification. And then we need to expand on our parse assignment so that it handles things correctly. And I think it's basically here that we need to handle. To start with, I'm just going to do a really simple way of doing it. I'm going to say that procedures are a special case. Remember, I don't like special cases. We'll undo this later, but just for now, just to get things working. So for a procedure, we'll parse a statement. Otherwise, we parse a right-hand side expression. Cool. I think that's that. When we type check our assignment, I'm kind of curious if anything changes here. So we need to change these parts. We still have a specific type check procedure. Yeah, that's why we have two loops here. We might be able to merge this one into the type check assignment. Yeah, let's do that. So that means we don't need to do this. We could just do it like that. And here, to know whether we're talking about a procedure, it's an assignment, and the first child, which is the left-hand side, should have a data type of procedure. So the left-hand side, so I think it should be like that. Okay. And now that I see this pattern, actually there was something I wanted to do. I want to change this just to bool. And I'd really like to do or return. Like that. It's a nice pattern in Odin. So if this returns false, then it'll just return the false. But if it returns true, then it'll continue down the rest of the procedure. Or in this case, it'll continue the loop. So it's nice. It's kind of like if something goes wrong, you can just say, okay, let's quit out. That's kind of the idea. So this is kind of a nice little thing that I wanted to improve. This one can be or return. I guess we can just put return here. Should be like that. Yeah, I guess so. If we didn't catch it here, then something went wrong. Okay, so now I have an or return. Or return. What's wrong with this one? Nothing. Okay. Nothing went wrong. That's right, I've already done or return in some places. So I'm just going to tidy up and do it everywhere now. Oh, that should be or return. Looks like I've already done that one, already done this one. Like so. Oh, why are they unhappy? Oh, because we don't need to go. We don't need to have that. Okay. All right. Whoops. Or return. Yeah, I guess we have or return here. We could just do return in that case, I think. But just to be consistent with everywhere else, we'll just say or return. Sorry, I know this is a little bit drudgery, but I do like this pattern a lot more. Okay. I think that's all that. So we were talking about the type check procedure could go in type check assignment, right? It's kind of part of it now. So it's like, you know, when we're looking at the right-hand side, we can say if, well, I guess if left-hand side data type is procedure, we do something special again, otherwise like this. And that something special is like this kind of stuff. So let's copy that, get rid of this, and chuck that in here. So actually we're looking at the left-hand side no data type. But is it still, well, we've already checked that the children are 2. We know we've got children 2. I think I'm going to cut this one out, but still say that I could even put this at the top, I guess. Just to say, you know, if we have a right-hand side, that is, we're assigning something to the procedure, but it's extern, that's invalid. You can't do that. So I think this is kind of the right-hand side node. Yeah, something like that. Since we have an error. Okay, so I think that's like our type checking sorted. Where did we have type check procedure? We must have had it somewhere. Oh, that's right, we combined it all together. So now in generation, there's probably going to be something similar we need to do. Yeah, so here we do need to find the procedure declarations and generate the non-procedures. Generate them here, and then the procedures need to go here. So it is a bit tricky. So if it's not an assignment, or the left-hand side of the assignment is not a procedure, then we know it's not a procedure. So I guess if it is an assignment and the data type on the left-hand side is procedure, we know it is a procedure. So that kind of solves that. Generate procedure, yeah, I mean, it's a whole different thing. I don't think we're going to try and merge that, the generation side. But what happens if we try to run that? Okay, I didn't think it was going to work. Generate procedure. So now this is, because we've aligned it with assignment, this is kind of the left-hand side node now. So we do like that, and that. And where do we use node? Nowhere else. Okay, let's try that again. Okay. So left-hand side, data type is bool. So why are we generating a procedure then? Ah, that should be an and. So we're generating an expression. Very nice. Something seems to have gone wrong. The resolved data type is nothing. It's an assignment. The right-hand side node is blah. Okay. Yeah, I think I remember we tried this in the last session and it failed then as well. And I just kind of ignored it. And I'm going to kind of ignore it again. Okay, exit code 2, so it works. If you just ignore that issue that we just came up against, it works. Cool. Happy with that. I don't like, though, that this is like handled manually. Basically, I don't like that we have this in places. Treating it as a special case. For these two generation things, that's fair enough. This one I want to change. This one is no. Ah, yeah, that's for procedures. We need to copy them early, so that one's okay. This one, we do need to do different stuff for procedure here in type checking. It needs to be type checked differently. You know, we need to create a scope. We need to make sure that scope knows about the parameters. Yeah, so I think that's fine. this here is copying the context. So we need to copy the procedures in specifically. So that's all good. I think it's just this one here that I don't like. And this is where I want to get into like being able to try and parse this and try and parse this and decide which one parsed best. And for that to happen, we're going to need to have a Boolean return. We're going to need to have something that says like, hey, did we succeed? I'm going to put it in this top level, procedure 2. And because if we like try parsing something, if there's an error, like at the moment, you try to get a token, it's the wrong token, it just throws an error and crashes. If we're in a situation where it could be one thing or it could be another thing, and we want to try parsing both and see which one succeeds, we don't want to even print out errors at that point. So what I want to do here is I'm also going to return a Boolean from this, and the token stream is going to have an error in it. And so we're just going to set that error. I think you can do like a printf. I think that like is basically allocates. Yeah, it allocates a string with whatever is in here. So I'm just going to say expected. Yeah, why not? Expected type, found type, and the two types. And then we're going to return false to say that was an error. And we'll do the same thing here for the value. And here we return true, of course, because it was exceeded. So we're really upping our parsing game here. Like, so we have a lot more control over the flow. So let's go like that. And return true. I guess node's true. So I kind of want to keep track of everywhere that we do next token. Because there's not going to be errors there. There are going to be errors for these procedure calls, but there are not going to be errors where we do next token. But with next token, we do want to do this or return business because it might fail. And if it fails, we want to just quit out at that point, quit out of the procedure. Okay. I guess it's like node true. So yeah, let's put all return on all of these and on this. We're just going to put like a whole lot of all returns around the place. Everywhere all return. If anything goes wrong, I think the pattern I tend to use is that I want to explicitly create a variable, because then it kind of allows me to give a name to it, like this is the statement node. And then I can mirror that name in future steps, and it kind of just makes it a bit easier for me to keep track of the structure of things. I need to also be careful to make sure that I'm returning correctly, because if I don't, because this is named, it's going to just be like false by default. So I need, whoops, put this everywhere. And we shouldn't have exit 1 either. Yeah, let's maybe tackle that a bit later, but we should not have any exit 1s. Okay, where are we up to? Looks like we're up to here. Yeah. I guess this doesn't need to be all returned because we're just returning. But parse primary, next token. And this should have an OK that it returns. Or return. No, yeah, we need to assign that node. Were there other places where we were assigning and I just like cut it out? Yeah. I think it was just there. I just remember doing it. It was totally not necessary. Okay, we've got an or return. So here we need to kind of like wrap it in brackets. Okay, cool, cool. Or return, or return. Lots of or return. That guy needs an or return. I kind of don't like that I have to manually put it for these guys. I don't know if there's like a no discard. You know, like in, I'm pretty sure in C++ there's this like no discard directive that you can use. And then it says you must like do something with the return value, which could be quite handy here to make sure that I'm not missing any of these next tokens. Because we really do need to check whether there was an error. Oh, I haven't been doing these returns. Okay. I think that's all that. Why are these ones all like errors? Ah. That's why. I guess that's the data type that we're returning. Okay, and now we're down to utilities. So I think that's all of those. And then I also wanted to check anywhere where there was, oh, missed one. Anywhere where we had like error handling, like this. So anywhere where there's exit 1, what I wanted to do is just say like stream error is that. And return false. So these should not happen. I'm going to say that that's should be an assertion. Just put it out here and say like return 0. And this is kind of silly, but let's just say like, maybe I could have a none in my enum. Just returning any old thing should be fine. But here, like script never ends, let's say that's the stream error. And we return false. And up here, do that. Okay. So all that refactoring so that we get these booleans returning, which I think means we need to say like parse okay, and if not parse okay. We get 2 spaces, it's so nice. Then failed to parse we'll give the error, but I also want to give is it in tokenization? Yeah, what did we used to have? Like at line and column, like that. The stream doesn't have it, but the next token would. There we go, so that should finish off our error handling. And we did all of that because now when we come into parse assignment, wasn't it? Parse assignment. In here, now we can attempt to parse a statement. So we're not going to do all return. We're going to do our own error handling. So I guess we'll just do the same thing for the right-hand side expression. And then we can say if not statement okay, and like if both of them failed, then it should have set our error information and we can just quit out. Oh, and another thing we need to do is, because they're going to mess with the stream object when we attempt to parse, and we don't necessarily want to save that. So let's make a copy of the stream for each of these. And then let's say like if the statement failed, we know they both didn't, we know they didn't both fail. So if the statement failed, that means that the right-hand side succeeded, and it's the only one that succeeded. So we return that node, but before we do, we need to say, okay, let's update the stream based on the right-hand side expression having been parsed. All right. So now if that's not okay, then we need to do the same thing, but we return the statement. So I don't think we need to do that actually. And then if they both succeeded, what I think I'm going to do is, like, it might have started with an identifier. Say it was like x plus 1 was what we're trying to parse. That's a right-hand side expression. So the right-hand side expression would have parsed 3 tokens. And when it attempted to parse a statement, it would have just parsed the x, and they would have looked for like an equals or something and failed. The plus would not have been a valid thing, so it only would have parsed 1 token. And in that case, I will say whoever parsed the most tokens wins. So if the statement stream next index is greater than the right-hand side expression stream next index, that means that the statement stream won. Let's do it around the other way. So if right-hand side won, then we return the right-hand side. Otherwise, we return the statement. Yeah, like that, I think. So I think that's kind of a dynamic way of saying, like, okay, let's figure out what we need to parse. But now in type checking, when we type check our assignment, where is it? Here. Now, if we're dealing with a procedure, we need to say, like, see, we're assuming that it's a statement, but the way that we've parsed it, the parser might have accepted a right-hand side expression. So to know if it's a statement has to be one of these things, right? So if the right-hand side node type is, so we're saying if it's not a statement. So if it's not if, and it's not for, and it's not scope. What's the way I can do this? I think like that. It's not return. There. So if it's not any of these statement nodes, I actually have a special way I want to handle this. Is it unhappy? Oh, I think this colon shouldn't be there. There we go. So if it's not those, then we should have found a right-hand side expression, right? And the right-hand side expression, so then we should be able to just, normally in a language, if it's like this, so we just have an expression, then you would expect that if I'm returning an I64, it should just return this, right? That's normally what you would expect. So I want to just do that. Why not? So that kind of means I think that we just need to wrap it in a return node. type equals return. I think we should give the line and column number also. So we'll just take that from here. So then if there's an error when it goes to parse the return statement, it should give us the right info. Was that just unused? Yeah. So then we want to append our right-hand side node to that. And then our right-hand side is a pointer, so let's dereference. And then we want to assign the return node to that. So that should effectively wrap our right-hand side node with a return node. Yeah, so for a procedure, you can either, either of these works. You can do a statement or a right-hand side expression. For anything else, it has to be a right-hand side expression. So I'm going to check if it's not. And if it's not, throw an error. So if it's any of these, it could be a call node, right? A right-hand side expression could be a call node. That's fine. Yeah, the fact that this, I'm just going to not talk about that. I feel like that's not quite right. But hopefully we refine these things over time. Failed to type check procedure. Well, it's not procedure, is it? Failed to type check assignment. And no one says declaration. Failed to type check assignment, and right hand side must be an expression. Like so. So I think that extra type checking should take care of things. Okay, it looks like we need to print if line. Failed to parse at line 15, column 10, but it doesn't tell us why. I think actually that might be because we just did this and we didn't give any error information. So we'll just give like the really basic failed to parse assignment business. Okay, so it wasn't that. Failed to parse. So those two have error info, that one has error info. They all have, I feel like they all have error info. Line 15, column 10 is the equals. So it's like assignment. Should be parsing assignment. That definitely adds. Let's come into here. Oh, it doesn't even get into there. If we step into this, parser primary, parser colon, step into type. Saying a Boolean, length 1, not a reference. I mean, it all makes sense. Ah, I didn't add the node true there. Hopefully that's the only place I missed. Okay, I think everywhere else is okay. So let's try that. Failed to type check statement. What node are we looking at here? A Boolean. Huh. And this is the top level of the program. And the statement node is a Boolean. Probably I'm assigning the type information incorrectly. Well, this is already the left-hand side node. So how do we get to type check statement and just have a Boolean? It's true, assert B0 equals true, test declaration from bool. So we're like right at the start here. We're at this here. It's saying that that is a statement. I mean, how did that get passed as a statement? That's what I want to know. Let's check our parse assignment because that's where we've done a heavy bit of work, and I wouldn't be surprised if we screwed something up. Okay. So we have a left-hand side node, identifier B0, data type bool, looking all good. We're assigning to it. So we try to parse a statement. We try to parse the right-hand side. The statement failed to parse, but the right-hand side succeeded. So we should go into here and return the right-hand side. Looks pretty good to me. Let's step into this second statement. It's a call. That makes sense. Let's step in. We've got the name node. Parsing a right-hand side expression for the parameter. We should do that twice. Close, come out. So then we have a call node. The first child, oh, that's the data type. The first child of the call node should be the identifier, which is assert and has a data type of null. Well, it doesn't return anything, so I guess it does have a... Yeah, the call node is what has the data type. So, but it's actually in type checking, right, that we get the issue. Maybe we haven't fixed that up properly. So let's go, oh. Let's type check statement. Wait, should I have not got type check assignment? So the node, where's our node? Here's our node. It's a Boolean. It's the true. Let's go here. Let's go to our type check and have a look at this first node. That's the first node. Is the Boolean true? Okay, so when we parse an assignment, we have a node, we add the left-hand side to it. Ah. Yeah, we shouldn't be returning these, we should be appending them to the node. Like that. So that's the statement node. Yeah, we should be appending them as the second child. We're not appending a second child. So let's try that. Take away the breakpoints. Right-hand side must be an expression. Just correct that formatting. Line 17, so it seems to think B0 is not an expression, I guess. Why would that be the case? Yeah, why would it be one of those? Let's put a breakpoint in here. Right-hand side is an assignment. And what's the left-hand side? Identifier B1. So shouldn't the right-hand side just be B0? What's the children? B0. Ah, okay, I think when we're parsing, we should favor the right-hand side expression. Because these two might both succeed, but in that case, this is going to get wrapped with an assignment or some sort of statement node, like assignment. Yeah, if it succeeds, it'll be an assignment. So it'll get wrapped in an assignment node. Whereas if this succeeds, it'll just be simply the whatever the expression is composed of. So we should favor that. It looks like we do favor that. Well, I guess it's like greater than or equal. So if they're both the same, we take the right-hand side expression. Okay, now what's the issue? So many issues. So we're generating a return. And do we have the context of the procedure here? I don't think we do. No, yeah, it should be in the context. Ah, no, not during generation. Okay. So it's a return, has a child, which is an add. So that is this, probably. That's the only place when so this is the return that we constructed, I think. So the first child of that should be, yeah, member 2 plus 2. So it's this one. And when we go to do the return, it's unhappy. So the expression node we've got here why is it unhappy actually? It goes into here and then it goes into here. And the operand data type, I guess, is null. So what is the left-hand side node data type? Also null. So that doesn't have a data type. It's member 2. Data type null. Why would that not have a data type? If we constructed the return properly, then it's happy. And can we call it and it works? Xcode 4. Yeah, so it's 2 plus 2. So that works, but when we take away the return, we get an error. And we don't seem to have type information properly. So when we go to type checking and we construct this return, we somehow don't have good type information. Let's have a look at it, eh? It's an add without type information. Ah, because we never actually do any type checking on this. And when we do the type checking, it would just, I think we do that because now it's a statement, right? So we should be able to type check it, and that should add the type information. Let's try that. There we go. Boom. Okay, that's what I had missed out. Sweet. Okay, so as a bonus, we can do this now. I think we've unified this pretty well. There is a little bit more I want to do to make it even better, but we're basically at an hour now. So I think I'm pretty happy with that for this session. I do think it's a step in the right direction. And the direction I'm trying to head towards is, this kind of thing. I really want to be able to do type aliases, but I've had to play with this and it's hairy. I really need to restructure things for this to make sense, because it means that basically types also become identifiers, and that has some implications because the current structure doesn't really support that very well. But that's what I want to do. I just want to have like everything as an identifier. Types, variables, procedures, everything is just an identifier. So then if you were to put something here, like if you were to put foo here, there would just be an identifier which during type checking would get resolved to a type and then pass. Like if it got resolved to something else, like an I64 or something, like a variable, then it would say, no, you can't put this here. But that's kind of where I want to get to. I feel like that'll be really nice, quite an expressive, flexible way of doing things. I'm already pretty happy with like this. Yeah, apart like if we could alias this, it would look much nicer. But I like the syntax. I think it's nice. Okay, enough talking from me. I hope you enjoyed. I know it was like just maintenance, but I enjoy this maintenance stuff. And I think I've been worrying too much about doing something that's entertaining, whereas I want to entertain myself. So There you go. All right. Thanks for stopping by. Have a good one. Ciao for now.